This lesson is going to be about undoing the distributive property, or in other words, factoring. You might remember that if you have something that looks like this, what you have to do is multiply this 4 times everything in here, which you got to do the distributive property. See, this probably looks familiar. Well, factoring means when I give you something that's this part, you have to tell me what two things multiply together, or more than two sometimes, what will multiply together to give me this. And so factoring using what's called the greatest common factor, all you have to do is undo the distributive property, or in other words, find that thing that was distributed into both of these. Okay, so all you have to do is look for what's in common to both of these terms right here. This is a term and this is a term. And so I say this is two terms, which is a binomial. It has a 4 in common, because this is 4 times x and this is 2 times 4. So if I pull out that 4 in common, I'll pull it out and I'll leave a set of parentheses, and I'll write down everything that's left. So I pulled this 4 out and I have an x left. And here I pulled this 4 out and I have a 2 left, with a plus sign in the middle. So that's how you undo the distributive property. Okay, now sometimes they're not always as easy to see what there is in common. Okay, so we can see here that there's at least a b in common, and since both of these are even, there must be a 2 in common also. Maybe there's something more. Maybe there's a 4 in common. Well, there's not, because 38 is not divisible by 4. Maybe there's a 6 in common, because 24 has a factor of 6, but 38 doesn't have a factor of 6, so looks like 2 and b are what we're going to pull out, 2 times b, or 2b. Pull that out, that means we're going to write it right here, and we're going to leave ourselves a shell and write down what's left. So 24 is 2 times 12. We're going to pull this 2 out, and we have a 12 left. And we pull out one of these b's. This is b times b. We're going to pull out this one, so we see that we have a 12b left over. Over here, 38 is 2 times 19, so when I pull that 2 out, I have a 19 left over. And I pulled the b out, so that's it. So this right here is your factored form of this. These are exactly the same, it's just that this is the factored form and this is not factored. Okay, so what if you factor something and you're not sure if it's right? Well, you could always check with the distributive property. You could distribute this back in. 2b times 12b is 24b squared. 2b times 19 is 38b. So this is the same as our original, so that must be correct. So that is how you factor a binomial. So why don't you try to factor this example? And I will wait for a second, or you can pause this and see if we get the same thing. You can see that 16 and 48 both have a factor of 16, so I'm going to take out that 16 in common. Both of these don't have an x, so I can't take that out. They both don't have a y, so I can't take that out. So 16 is the greatest common factor of these two. And I will write down what's left. 48 is 3 times 16, so that means this is a 3y left over. And now that you've mastered what factoring a binomial is all about, sometimes you have to do that twice. And when you have 4 terms, 1, 2, 3, 4 terms, you have to do the method we just talked about twice. So this is called factoring by grouping. If you ever hear somebody say factor this by grouping, that's what that means. Obviously you'll want to group things together. Well, what we're going to try is to group these two and group these two, and then do the procedure that we just talked about. In other words, what do these two have in common? Well, they have a 4 in common, and they also have an x in common, so that's what we're going to pull out. We're going to write down what's left. So if I take out a 4x out of 12x squared, I have a 3 and an x left over. If I take out a 4x out of 4x, the temptation is to say that I don't have anything left. But this is actually 4x times 1, so if I pull out this 4x, I have a 1 left over. Another way to think of this as I'm actually dividing each of these by 4x. So 12 x squared divided by 4x, that gives me 3 and x. And the same thing, 4x divided by 4x. Well, anything over itself is 1, not 0. So that's why this is a 1. Okay, we're going to look at these two and see that this has a negative 2 in common. They each have a negative, and 2 is the only factor that they have, so we're going to write that here and write down what's left. Negative 6x, I pull out a negative 2, now I have a positive 3x. Again, you can think of it as I'm dividing this one by this one. Negative 2, I pull out a negative 2, I have a positive 1 left over. Again, you can think of it, divide negative 2 divided by negative 2, you get positive 1. Okay, so that was the first time I'm going to group. Now, look at this term and see if they have anything in common. And you can usually see that this part right here will be in common. And you can take that out of each of these. So I'm going to take out a 3x plus 1 because that's in common to both of these, and I will write down what's left, which is a 4x and a negative 2. See, my 4x is here, my negative 2 is here. If for some reason I'm not sure that I did this right, I could multiply these two back together and hope that I get this. And here you'd have to do the distributor property twice. You distribute this one and this one. And you should get this. So here's one for you to try. Again, try to group these and these. Pause the video and see if you can get this without my help. What we're going to do is take out the 2 and the y right here and write down a 3y minus 2 left over. Right here, these don't have anything in common, but everything has a 1 in common. So we're going to take out that 1, a positive 1, and write down what's left. Okay, that's kind of the tricky part. Everything has a factor of 1, so these have a 1 in common. If it doesn't appear that there's anything in common, there's at least a 1 in common. Okay, now I'm looking at this term, and I can see that they have this 3y minus 2 in common right here. So I'm going to take that out of each of these and write down what's left, which is a 2y and a 1.